right, in this instructional video, we're going to talk about equations that may not be in quadratic form, that we're going to use a process called substitution to get them in quadratic form. Now, this is written here. Notice we've got AU squared plus BU plus C equals 0. And this equation is said to be in quadratic form. Now, you could put AX squared plus BX plus C or any variable in there. But this is the good old quadratic form that we've been talking about throughout the chapter. Now, what if some dirtbag scumbucket gives you one like this, x plus 1 raised to the 2/3 power minus x plus 1 to the 1/3 power minus 2 equals 0. Now, one thing I want to review real quick here, and I'm going to clear off this slide before I go on with this example because this is very important here, is the rule that if you have fractional exponents, let's take x to the 3/4 power, that really that is a radical in disguise, all right? This can also be written as the 4th root of x cubed. So I've got an old saying I like to use. I used to like that show ER on TV a long time ago. It's not on anymore though, but I like to say E over R when it comes to fractional exponents. And that means exponent divided by the root number. Exponent divided by root. Okay? So let's try a few more examples just to get that down because it's going to be real important. Y to the 1/2 power would be the square root of y. Now students on this will go, wait a minute, Young, where's the 2 and where's the 1? On a square root, they never write it, but it is a 2 there, that's why I call it a root number, 4th root, square root, cube root of y to the 1st. All right, they may give you a to the 2/3 power. That's a bad 3 here. Let me fix that. And that would be the cube root of a squared. So be very careful and remember this exponent divided by root, and it will help you as we continue. Now back to the problem here. So what we're going to do here, notice this problem's in descending order. So what we're going to do is let u equal this middle term, x, to x plus 1 to the 1/3 power. Okay, so we're going to go ahead and let u be this whole middle creature. And when we do that, notice wherever we see an x plus 1 to the 1/3 power, we're going to plug it in, we're going to plug u in for it. Now notice here on this rule, if you plug this in here, whenever you raise a power to a power, rules for exponents say you multiply the power. So substituting in x plus 1 to the 1/3 power for u changes this very ugly thing up here, nasty, mean thing, into, look down here, something very nice. We're going to say, so this process of substitution will take something ugly and make it nice. So here's our nice quadratic form. So we factor, we get our 2 answers for u, but we're not done yet. Once we get these answers for u down here, we're going to have to take and solve. Remember, we were asked to solve for x way up top there. So we have to go and plug these back in so we can solve. All right, so notice here, if u equals 2, then x plus 1 to the 1/3 power equals 2. Or if u equals -1, x plus 1 to the 1/3 power equals -1. Now, what they're not showing you here is what I showed you earlier, if you want to think of it this way. That middle term, x plus 1 to the 1/3 power, is really the cube root of x plus 1 to the 1st power, if you wanted to look at it that way. And remember, anything to the 1st power is itself, that's a bad 1 under there, equals 2. And either way, what you're going to do to solve is cube both sides of the equation. See, so when we got done doing that radical section, if you want to think of these in radicals, it helps some students understand. And then you'll go ahead and you'll get your answer here. So you'll get, when you cube the 1/3 power or cube the cube root, you're going to get x plus 1 equals 2 cubed is 8, and subtract 1 to get the 7. Same thing over here, you'll say x plus 1 equals -1 cubed. will be -1. That's -1 times -1 times -1, subtracting 1, and there's our two proposed answers. Will they check? You know, that's always the thing to plug in. They will check if you plug them in here. Now, I know what some of you are saying, Young, that looks beastly to check 7 or -2 in here. So let's go ahead. We'll plug 7 in here real quick. So that would be 8 to the 2/3 power. We plug 7 in. Minus 7 plus 1 is 8 to the 1/3 power. Minus 2 equals 0. Now remember, 8 to the 2/3 power is the cube root of 8 squared. You can also take that number 2 from the inside on the 8 to the outside, minus the cube root of 8 to the first would be, you could leave the 1 in there, you could put it outside, minus 2. And notice the cube root of 8 is what? 2 squared, so this would be 4 minus 2 minus 2. And indeed, that will come out to be 0 and check. And so will -2 if you plug it in there. So always check, even the most vicious type of equations. Now on this one, notice it's not in form yet, so we first want to get this equal to 0. And in this one, we're going to let u equal this middle term here, x minus 1, to the -1st power. So we're going to go ahead wherever we see something on some of these more strange looking equations, and we're going to substitute u in there. And then notice it says over here, if u is x to the -1st power, if you square both sides, then u squared will be x to the -2. And that's how most of these work. If you let u or some other variable be that middle one, then u squared will be the one in front of it, thusly changing it again from something, I don't know if this one's ugly, but I'll put that again, to something nice here. Substitution helps us there. So we can factor and get these two answers for u, and then we have to plug them back in. So if u equals -2/3, then x to the -1st power equals -2/3. If u equals 1/2, then x to the -1st power is 1/2. And notice, what is x to the -1st power? So you kind of have to review how good your rules for exponents are. That this just means 1 over x. So if you take the reciprocal of both sides, see, if you flip it, which you're allowed to do, you'll get the two correct answers here, and this would be 1 over x equals 1/2. So, or you could cross multiply and set them equal, but you'll get your answers of -3/2 or +2. I'm sorry, and I do believe, let's see here, that both of those answers again will check. All right, let's do one last example here, and we will call it another video. So in this one, they give us higher powers. They give us x to the 4th power and x squares and stuff. But again, this is not in quadratic form. So we're going to let u in this one be the middle one again, x squared. And notice again, if you square both sides, then u squared will be x to the 4th. So again, we're not familiar with these equations of different degrees, but we are always trying to get these in our nice form, ax squared plus bx plus c equals 0, which our author just threw a u in there instead of an x. It's still the same quadratic form. So again, excuse me, something ugly becomes something nice, which we'll factor here, and we'll get our two answers of u equals 2/3 or u equals 1/4. Now be careful on this one, because when you say that if u is x squared and you go and substitute it back in there using substitution, remember the square root principle. When you take the square root of both sides of the equation, you will get not one, but two answers, plus or minus the square root of 2/3 or plus or minus the square root of 1/4. which they rationalize that square root of 2/3. They don't like radicals in the denominator, so they go multiplying both top and bottom by the square root of 3 here. Now this one comes out nice because the square root of 1/4 is 1/2. And you get your two answers, plus or minus the square root of 6/3, plus or minus 1/2. Now note here, some equations that are quadratic in form are simple enough to avoid using the substitution variable technique. Now on this one, we could have factored this directly, setting each factor equal to 0 and solving the two resulting quadratic equation. It's a matter of personal preference which method to use. Now some of you may have seen you could factor this in the first place without using substitution. Now, I don't know if that's true on the other ones we did with those nasty fractional powers and negative powers and stuff, but if you can factor, by all means, it's not my way or the highway. All right, now notice on this one here, we've got this 5x squared minus 6 to the 1/4 power equals x here. And again, this 1/4 power, if you remember, is really the 4th root of 5x squared minus 6. Using the E over R method to the first power equals x. So on this one, they just raised both sides to the 4th to take out the 4th root. Notice they didn't even change it to a radical because they know if they see something with a fractional exponent here that we're always trying to raise it to a power, and when we multiply, we get a 1 there. And then we get down here to this step, where again, you kind of have your choice. You can factor from here if you see it. Now, some students might be able to factor this. Some can use substitution and let u equal x squared here and change something ugly to something nice. But see, this one you might be able to factor. Either way, think about that. And you will get u minus 3 times u minus 2. If you go the nice way, is 0. You'll get your two answers. Plug them back in, and notice here you'll get plus or minus the square root of 3 or plus or minus the square root of 2. But when you check this one, ladies and gentlemen, only the positive answers work. You will not be able to check the negative ones here. So again, always check and make sure that your answers make sense. So if a substitution variable is used when solving an equation that is in quadratic form, do not forget the step that gives the solution in terms of the original variable. So again, if you let x be u or some other variable, make sure that you check it in the original equation. All right, Bob Young signing off. We'll see you in the next instructional video.